Hello, and we're recording. Hello, Algebra 2. We're looking at lesson 7.4. Let's dive in. So, last video, we were multiplying and dividing irrational expressions. Now we are adding and subtracting irrational expressions. At their core, a rational expression is a fraction, okay? And how do we add fractions together? Well, the main thing that we learned in, good old elementary school when learning fractions is that we need a common denominator. We must get a common denominator, all right? So we can add these together. 3 plus 6 is 9, and we get 9/5. We can subtract these, and 7 minus 4 is 3, and we get 3/5. But what happens when the denominators aren't the same? Well, we have to get a common denominator. So we have 5 and 7. Well, how can we transition or convert those into the same denominator? Well, you can't just do anything you want to it. But why is this legal? Why is it allowed to multiply by 7 over 7? Because at its core, 7 divided by 7 is just the number 1. So when you multiply by 1, you're not actually changing anything. 3/5 and 21/35 are the same thing. And when we multiply by 5 over 5, that's, again, just multiplying by 1, and 1 doesn't change anything. And that means 4/7 and 20/35 are the same thing. It's just a different way to write it. So now that the denominators are the same, we're able to add them together. Okay, that's just a brief synopsis of fractions, right? We must get a common denominator before we can do anything. So what we're doing here with these first few examples is simply finding the common denominator. And we're calling it the least common denominator because we want the smallest one. We want the least obnoxious, so to speak, denominator. So how do we go about that? Well, it all comes down to the factors, right? These are not the same denominator. If we factor this up, though, this factors into 2x minus 1, 2x plus 1. Well, we can see here that they have a little bit in common, but they're not entirely the same. So what would we do to make them the same? Well, if this part is already shared, we need to multiply by 2x minus 1 in order to make these guys identical. I hope that logic makes sense. So my least common denominator is 2x minus 1, 2x plus 1. That's what the denominator would be in the end. Looking at these guys, right? Don't get fooled by, oh, they both have a 4. Not quite, right? That's one factor and that's one factor. So in the end, our LCD would be 4 times x plus 4, right? Because this would get multiplied by 4, and this one over here would get multiplied by x plus 4, right? So that way they are the same. I hope you see what I'm going for. I'm trying to make the denominators identical. The last one, right, when I split this up, I end up with x minus 1, x plus 1. And this here has x and x plus 1. So the least common denominator would be x times x minus 1 times x plus 1. Another way to look at it is that it has to have one of each. You can't get rid of either one of these, right? You might look at this and go, well, this has an x plus 1 and so does this one, but let's just get rid of the x minus 1. You can't get rid of it. It has to be included. So it's just like one of each. One of this guy, one of this guy, and one of that guy, right? And in the end, we end up with that. So that's our thought process going into each of these, right? How do I make them the same? Okay, well, this is super easy. Boom, this adds to be 7 plus x over x minus 2. I'm literally done. When you add fractions, the denominator stays the same. You're simply adding the numerator. We're literally done. You could also write this as x plus 7. Okay? Those are the same thing. Okay, jumping into the next one. We have to factor this up, which factors into x plus 2, x minus 1. And then, oh, this is a factor, already has the factor x plus 2. So we're missing the x minus 1. We have to multiply that in. When we multiply by x minus 1, what does this become? Well, this first term stays exactly the same, right? Because we didn't multiply by anything. But when we multiply by x plus 1, this becomes x minus 1 over x plus, well, maybe, should I leave it factored? Yeah, let's leave it factored so we can see that the denominators are the same. Right? I multiplied it in, and now, voila, we have identical denominators. Why did this become x minus 1? Because 1 times x minus 1 is simply x minus 1. And now we add these together. X plus x is 2x, and then minus 1. All over x plus 2 times x minus 1. Let's do another one here, and let's have our first question. So let me write this out with some more space. All right, so I separated those x's. Take a look at the terms here. This question is going to be multiple select. Take a look at these denominators. What is this first term missing? They need to be exactly the same. It already has one x. What is it missing when you look at the other guys? Answer pops up. So you should have said that it's missing an x, an additional x, and the x plus 3. Okay, another question pops up. What is missing from this second one? It's already got two x's. What is missing? You should have said, well, it's only missing the x plus 3. And you look at the last one. What is it missing? All three denominators have to be the same. What is missing from that guy? It's missing both x's. It's missing both x's. So now, when you multiply this all together, we're going to have common denominators. So I'm going to leave, I'm gonna write the, I know this seems tedious to write this out, and it is for me, right? And if you're following along with the notes and you're writing this, you're like, man, this is a little tedious to write. But I just really want to reinforce that the denominators are the same. And now what happens when we multiply this together? 4 times x is 4x, and 4x times x, so 4 times x is 4x, and then 4x times x is 4x squared, and 4x times 3 is 12x. 2 times x plus 3 is 2x plus 6, and then 4 times x is simply 4x squared. So when we add this all together, 4x squared and 4x squared become 8x squared. 12x and 2x add to 14x. And then we get a 6 all over x times x plus 3. Feel free to rewind that and go back and look at my thought process, okay? All right. I'm not going to ask for the denominators this time, but rather let's ask how it's going to multiply together. So I look at this, I got this factor, and this factors into x plus 3 times x minus 1. So this one already has both. So this one needs to get multiplied by the x plus 3. And this one needs to get multiplied by the x minus 1. Sorry, it's getting a little cramped there, but I hope you can forgive me. So, let me write it out pretty. Let me write it out pretty for you because I'm about to ask you a question. So, I'm multiplying this by x plus 3. Start to think because I'm about to ask it, but it's not on the screen yet. How are these going to multiply together? I just scribbled over it. How is that going to multiply together? Start to think about that as I write this down. I'm running out of room over there. Okay, so did you think about it? How is this going to multiply together? A question pops up on screen. When you have a factor times a factor, you might find it useful to use the box method. So it becomes x squared plus 5x plus 6. And another question pops up on screen. This one's a little bit quicker. What are these guys going to multiply together to become? All right. I forgot to write my denominator here. It gets tedious, right? 2x minus 2. I'm just simply distributing the 2. So now that we have the same denominator across the board, we just add together our like terms. So x squared, there isn't another x squared. 5x, 2x, and x is 8x. 6, negative 2, and negative 6. Well, those cancel, and I'm left with minus 2 all over x minus 1 times x plus 3. Pretty nice, eh? It is a little bit of work. I will admit. However, it's just organization. Keep things organized. Keep it organized, okay? Write out this multiplication. I initially crammed it in, but then I realized that you know what? That's not beneficial for anybody, right? Keep it nice and clean, space it out, give yourself that room. Take your time with it, okay? So, write an expression for the perimeter of the figure. Perimeter just means to add all the sides together. Well, this figure, right, the bottom is the same, or the top is the same as the bottom, and the right is the same as the left. So when we find perimeter here, we're adding that to itself. That is the top and bottom. And then we're adding top and bottom, and then we're adding the right and the left together. So when you add those two things together, right, these guys right here, they already have a common denominator, right? They already have a common denominator. So they just, boom, it adds together. 14 over x plus 4. And these already have a common denominator because they're the exact same term. So this becomes, boom, 4x times x minus 3. Now, in order to combine these guys together, we have to once again get a common denominator. So this needs the x plus 4, and this needs the x minus 3. And when we multiply that together, they'll be the same. So this becomes 14x minus 14 times 3. I feel like I'm going to screw that up. I don't want to screw it up, so I'm punching it in. 42. And then this one here becomes 4x squared plus 16x. All over x minus 3 times x plus 4. So I ask you another question. What are these two terms going to add together to be? Ignoring the denominator, because we know the denominator is going to stay the same, just add that together for me. And answer pops up on screen. There's only the one x squared term, so that's just as chillin'. And then 14x and 16x become 30x, and then minus 42, all over x plus 4 times x minus 3. And there it is there. These last four are subtraction. We're at the 15-minute mark, trying to keep it under 20. So we just might do 2 of these, and so that way it'll keep it under. So expect 2 more questions, okay? I'll let you know when the last one comes up. So let's do 2 more questions. So, well, let's do 3, honestly. Well, I'll do 3 of these. I'm not going to ask a question on this one, right? The denominators are automatically the same. Boom. It's that quick. It's that easy. If the denominators are already the same, it's the easiest problem in the world. Right? 8 minus 3 is 5. Oh, this is interesting. This is the first time we're seeing this. Here's a question on screen. What is the denominator for this 4? I don't see a fraction there. What is the denominator that I can create for this 4? All right, hopefully you thought to yourself, well, write 4 over 1. Exactly. And you don't really, multiplying by 1 does nothing. You can do that if you want, but obviously here we need to multiply by x plus 3 because clearly that is missing, right? So when I multiply those two things together, we get 4x plus 12, 4 times x, 4 times 3, minus, and that literally is just 5 still. And now we can subtract these things together. This is a whole number. Be careful about this subtraction, right? Don't, these problems potentially might be mixed up, and I don't want you to all of a sudden be like, oh, it's just adding, right? It's 12 minus 5, so we end up with 7 over x plus 3, like so. All right, so be careful about that, okay? We might be able to do all 4 of these. Let's see what happens. Right as I say that, there's 3. Okay, this might be the last one. So let's have question galore in here, and then we'll end on this one. Factor it, and I like to, let's, I'm going to sneeze. Excuse me. I like to give myself some space because I know I'm going to multiply by something, right? Incoming multiplication. So I'm giving myself that room to prepare for what's coming, all right? And what does that factor into? X minus 6, nope, sorry, plus 6 minus 1. 6 minus 1 is positive 5. So incoming multiplication. This is missing, so this matches, but this is missing the minus 1. This already has the minus 1. So this only needs the plus 6, and this only needs the minus 1. So now all 3 match, right? So now let's do that multiplication. I already had you do this. This is box method right here, right? So I won't ask another question about that. This is x squared, 6x, 2x, and 12. So this becomes x squared plus 8x plus 12 all over x minus 1, x plus 6, minus, we'll just keep it going. This is 2x minus 1 all over x minus 1, x plus 6. And then this, we didn't do anything extra, so it's just chilling. Now, I want you to, this is a halfway step. Ignore the minus 14 for a second for me and tell me, what's the result of subtracting these two things? Ignore the minus 14 and tell me, what is the result of subtracting 2x minus 1? Question pops up on screen. So, this was challenging and you might have just got it wrong. When I subtract the 2x, I'm going to get 6x. But when I subtract 1, I'm adding 1, right? So that becomes 13. right? Not 11. I don't know if you did 11, but you might have been tempted. Now, this is just straightforward, minus 14, so it drops down to minus 1. Did I make a mistake? Pausing real quick. Guys, I made a mistake. You might have caught it. Good thing I didn't ask a question about this one. So this, I multiplied the 2, but I totally forgot to make this minus 2. So this is actually plus 2. So this becomes 14. And then 14 minus 14 is actually 0. Interesting. And you know what? It's something else is crazy interesting. This is we're about to end it right here. Video's almost over. You answered the last question. Good job. What is crazy interesting here, though? There's a GCF. So after the subtraction, I can actually factor even more, which is kind of crazy. I can factor out that x. And look at that. Look at that. Look at that. Look at that. This cancels, and I'm left with x over x minus 1. That's unique. That is fascinating. All right. Thank you for watching. I hope it wasn't too long. Um, be ready for the Socrative. Hope you're having a good weekend. And yeah, I'll see you later. Thank you.